A very wonderful good day to you guys. Today I would like to talk a little bit about the Chinese K40 laser and my attempt to basically take this wonderful laser tube, which you can see is the standard 40 watt laser tube. You can get it in different versions, and exchange it to that little sweetie here. Oh my gosh, that's a 130 watt 1 meter and 62 long laser tube. I thought it might be interesting for you to see how well this thing is packed or not packed. So that's not, I didn't have a look into that box, so you will be able to witness maybe a cracked tube, who knows, live together with me. So I will just start and try to get all the styrofoam out of my way, and I can immediately see something which I like, which is another box in the box, just to prevent that thing from cracking. Appreciate that, and I will be with you or back with you in a second. Let me just try to get that styrofoam out of my way. Alright, as you can see now, I pretty much removed all the stuff that was in my way to open that box. I still think it will be a little bit difficult to deal with the package with just one hand, but let's see how it works. Try to gently lift the cover, and there you go. Wow, that's a beauty, and it's such a big one. God damn. Let me just put that stuff out of my way and have a first look. Jesus Christ. Honestly, now I'm a little bit scared. I am a little bit scared. Funny enough, if you have a look at this label, you can see it's been built somewhere around November 2020, and it's rated for 130 watts and a peak power of 140 something. So I think this guy will probably last longest somewhere around, let's say, 100 watts. Don't know, we will find out. So far it looks in perfect condition, so no damages at all, which is good news. So matching that totally stupid large laser tube, I just would like to introduce to you Mr. Power supply, rated at 130 watts, which should be totally fine to power that tube, because as we all know, these tubes really don't like to run at full power. So I guess running it around 80% is more than enough. And yeah, the first challenge, and that's basically what you will see today, if at all, is as you can see down here, there's just a few inputs, and these inputs are everything you have to basically power that thing and have it operating as the old one. And I will quickly switch over to the actual power supply, which is in here. And as you can see, there's quite a bit of inputs that have to be rerouted. Alright, I put on my light gear, so I think you should be able to see more clearly what's going on, and I think we start over again, coming from the point where I tried to somehow explain to you how that thing works, the old power supply compared to the new one. So as I stated already, we've got the anode out on the very left, at least on my power supply, I know that there are different versions of that power supply around, so don't take that for granted. So anode out, then we do have the protect earth, the second yellow wire, and then the two red ones are basically neutral and phase for our mains. And I think that's pretty straightforward. If I take the bigger power supply, you can see the PG, or FG, which should stand for the ground connection. Then we do have the two ACs, and on the back side we've got that nice little wire coming out, which is the anode. So, and that's the high voltage out, the cathode. So no problem here. And then we will talk about these connections here, which are a little bit of a problem, and I will tell you how I try to connect them. So that thing is heavy like shit. On the very left, these two ports, I know that they are for the micro switch, which protects the lid, and the enable switch, which is this one here. So they are in series and they are connected to these two. In addition to what I said in the live video, I think it's important to very quickly go over some details about the safety functions. This is the power supply we are talking about. And basically what I want to point out, and that's why I only draw these two connections. What's behind here in this box is a big question mark. You don't know. That being said, if you connect your switches, so let me try to draw that one quickly. So let's say that's the lid switch. And let's say you even connect your next switch like this one, which is your, oh, let's see. That's your actuation switch, and you kind of connect them like this, for example. This is everything but not safe. There's so many things that can go wrong that I just wanted to stress that point and just tell you that you really have to be careful about that. I know a lot of people say something about laser safety and all that stuff. It's not my point to tell you something about laser safety. I just want to point out that all these so-called safety circuits are not really a safety circuit. First, what you normally would do is you would try to find a kind of redundancy in your externals. So this part here, let me see if I can point that out. This part here, that's basically absolutely just one single failure safe. So let's say you closed your lid by purpose, or let's say you activated your switch by purpose and you open your lid, but this switch just stays in the down position. There's no one that will protect you from this power supply sending power to the laser tube and emit a high power beam to your hand, to your eye, whatever. So this is the first thing. This circuit is not safe. It's just two switches connected in series
There's no redundancy or something like that at all. You could make this one safe by adding another switch or using different switches, all kind of stuff you could do to make it as safe as possible. But the thing is, and that's what I really wanted to stress out, even if you do so, there's another problem which is located here. You have no clue what's inside that box. And I won't tell you because I won't open my power supply. Maybe in a further session I will open the old one and just have a look inside, but I definitely will not do for the new one. It was quite expensive. In fact, it was nearly as expensive as the whole laser was, and I'm not opening that one. So what I want to say is basically you can maybe get the externals as safe as possible, and it might be a good idea to do that, but you don't know what's going on inside here. If that's a circuit like I assume it is, then there's not much stopping you from having that laser beam just fired accidentally whenever this power box, this power supply wants to. So have that in mind whenever you are working at that laser and there's a chance that you have a look at the beam or at the reflection of a beam, you probably want to have something else protecting you from that.
Then we've got two yellow wires. I guess this one is connected to the actual, I don't know if you can see it. I think it's connected to the test button because there's a yellow wire going onto that. And the second yellow wire, which is also connected to the test button. So I think these two guys here are actually for the test button. One is connected to ground, which is the next port here, that's the ground wire, and one is connected for the input of the test switch, which I don't have. So if you have a look here, there is no damn test switch. You can push that little button here, but I think we agree that's not the solution. You don't want to open your box and touch the test button on the power supply. So we need to figure out how that works. I've got an idea, but I'm not sure if that will work. And then we've got the ground wire. Then we've got one blue wire that is connected to the potentiometer. I hope that's spelled correctly or pronounced correctly. And this one is the positive. So that's 5 volts plus to ground. And on the potentiometer, we've got the same setup. So that's pretty straightforward because we have the same setup here. Oh, that thing is so heavy. So we've got basically the +5 and the ground, and there's one port that is labeled with in, and I'm pretty confident that you need to wire your potentiometer to that port if you don't use software and a controller to regulate your power output. And there's a low input for the actuation and a high input for the actuation, and my plan is that we will use the test switch connected between ground and the high power output, and then there's a input which is labeled with P, and I think this is the water protection. And what we will do is we will wire our both switches, so the lid switch here and the main switch, we will wire them to ground and P. So only if both of them are closed, we will have a actuated power supply. So what I will do next is I will start to rewire that whole thing, and you can just have a look to it and then I know what's happening. So let's start with this connector, which is basically the protect earth and the two faces, we won't have this one connected now because this one will be reconnected to the back of the new power supply. So let's start with unwiring all that stuff. Sorry for the shake. I'm probably gonna take this one and put it right to somewhere where I can't miss it, because I have to verify if that's the correct one. We're gonna take this one out. That's the protect earth. As you know from all the other videos out there, this is one of the most important wires in every K40 laser, no matter if it's modified or not. I'm gonna make sure it's nice tight connection there. All good. I'm sorry for the shake again. That's a little bit hard to work like this. Oh, that one wasn't even connected correctly. Scary. Really scary. I mean, there's not much load on that clamps, but even though, ruining your system by just having loose connections like shit. Don't know if I like that. And last one. Oh, that one also wasn't connected pretty tight. So, first shout out to all of you K40 users. Use a screwdriver to properly fasten your screws from the power supply. It looks like they haven't been fitted correctly. Okay, next thing is our protection circuit. So let me get this one out of the way, because that's nearly finished. And I will start unscrewing these two guys here, which I think is the protection circuit. So this switch again, and the switch which enables or disables the whole laser function. So get that one out. It's scary, they are all not really tightened down. So, and just once again, so you get the idea. Maybe I put in a circuit drawing afterwards. I will use the P, which I'm pretty sure is the water protection, and the G, which stands for ground, to just enable or disable the whole laser setup. I'm lazy, so I don't hold the power supply all the time. I just take out the connectors and have a double check. So that's the third screw, which is this guy here. Tighten that down. You can see it's way too long. Way too long. Anyhow, I think for the moment that will do. And then the next one is actually already ground. So that one will be on ground. And I know that I will have to unscrew this guy for 1,000 times from now on. Let's see. So the next two guys are actually the test switch. And as I said, I think it's totally okay if we rewire these guys and put them between the... Oh, this one is... No, it's loose. I thought it's connected. So these guys, doesn't really matter how, but they need to go... If I'm correct, I would wire them up to the very first pin, which is the high input. which should be good for anything above a certain voltage. I think it's somewhere around 3 volts. So if I wire this guy up like this and just tighten it. And this guy for 5 volts, which is the very right pin. This should work like a charm. So actually we are nearly done already. So this guy is ground, which if I remember correctly, oh, you can't see anything, right? I'm sorry guys, it's really hard to film that stuff and in addition keep the thing going. So I will unscrew this guy again, which is ground, I think. I'm pretty sure it is. And add this ground wire and there we go. And then we do have the +5, which should be this guy, which is also loose. Interesting. So again, a brief reminder to really get that tightened correctly, no matter if your K40 works fine or not, don't risk it. And this guy then needs to go to the in, which is, you can't see, I'm sorry. So this guy I think needs to go there. Having a electronic drill and not using it, or electronic screwdriver and not using it, isn't the smartest of all ways. Okay, now I have to double check where these guys come from and where they go. I know for sure this one is 24 volts plus, this one is ground, and I am thinking that these two guys actually are the control outs. So I will double check this one and come back to you. Okay, I just double checked and now I'm pretty sure I've got it correct. So these 4 guys here, let me take it out. From left to right we can see 24 volts ground, +5 volts, and then the mysterious negative activation signal for the power supply to turn on the laser. So I actually have the problem that if we have a look to that power supply here, we don't have any kind of plus 24 volts. So we need another power supply for that. Unfortunately, I wish I would have another chance, but this is really the downside of that power supply here. We don't see the 24 volts anywhere. And then we will use the low input and the ground to connect the 2 signal wires, which are basically the black one and the yellow one. The yellow one will go to the low and the black one will actually go to the ground wire as well, and then the blue one will go to the 5 volts pin. Let's see. Just put that power supply away for a moment, and then here's our connector, and I'm starting with the yellow one, which might be the most interesting, and put it onto the low pin. Then we've got the plus 5 volts, which is the farthest right pin. And I hope that this power supply has enough amperage to supply all these guys with some juice. And then we have the ground wire, which actually and certainly comes to the ground pin, which is the third from the right. So 1, 2, 3, there you go. This guy needs to take all these wires. I don't know how that should gonna fit. And I've lost a few of them, so quickly put them back in that. You know what, I'm just opening that one a little bit more, maybe it's easier. So 1, 2 and 3. Oh, this one is ruined. You know why this one's ruined? Because I already took out the original fan from the dust extraction, because it was a nightmare. Isn't this really way too loud, don't you think so? So this is all good. The only thing which is missing at the moment then is the 24 volts for the stepper motors, and I won't connect this because I just want to test if everything works correctly. So I don't connect this one, but from the rest I think this is how it could work, but we will see. So I just took apart out of the original position the old power supply. Nothing fancy here. I had to cut the high voltage wire, and I'm still hoping that this doesn't cause any problems if I need or want to get back to the original setting. There's nothing spectacular in there. You can see a flyback transformer, which was totally certain that there is a flyback transformer in there, and this guy generates the high voltage output. And yeah, that's basically it. Hopefully there's enough space for the new power supply. Let's find out. So I need to take some cables away from all that stuff, and just quickly put it onto the ground again. And now we will see if the new, we can make a size comparison just for the sake. So that's the new power supply. Now we can, you know what, I just put it in there. I think you can already imagine that this guy is quite large and awfully huge and all that stuff, blah blah. Okay, now quickly let me show you the test setup. So I've connected all wires according to my idea how I should connect them. I also connected these guys, and I just see that I forgot to do this connection, which is the anode. This connection has to be done, and then I am just verifying that I've got a decent water flow. I've got that tube still in its original box, and certainly I will cover it, so the risk of getting radiation everywhere is as low as possible, at least at my point of view. And I have no air bubbles, at least no visible air bubbles in the whole system, so I'm pretty sure it shouldn't overheat at the first glance. And this is the ray output, so there should be the high power beam, and I'm planning that this will be burned immediately. And I'm not sure if I even will have an opening here, just to have the beam going all the way to here and just hit the wood so that I can see that the tube is working. That's basically all I want to do for today. So I've got water flow. That's an upgraded pump. It's not the original pump that comes with the K40 laser. It has 1,000 liters more of water flow. And again, I will basically cover this whole thing with the box it came with and hope that I will survive that test. Well, let's see. I will position you in a way that you can see better than I maybe. Give me a second to wrap that up. Okay, here goes nothing. Alright, after some modifications, I'm gonna go and switch on that power supply the second time and wait until the van is fully up to speed and then see what happens. So I don't know if you can hear it through that microphone from my mobile, but there's a lot of fan action going on. And what I will do is, before I start to push some buttons, I try to barely move that camera so that you can see what I'm touching and why, because I want to verify my setup. So first, I think the most important stuff is going on in this shot. So if I, there's this lid here, which is at the moment open. So there's this safety switch and also this laser switch, which are both not switched on at the moment. So in theory, if I hit that test switch, nothing should happen at all. And we will find out in a second, as I just hit that button very shortly. So there's nothing. I just crank up the amperage a little bit to see if it's because I cranked it down all the way. So that didn't work at all, which is good, which is the supposed and intended way that switch should work. So now I'm gonna close that lid, which means that now the first of two safety switches is engaged. This is the second one, and I try to hit that test button once again, but I'm pretty confident nothing will happen. So nothing happened, and now I very, very shortly just hit that button. Nothing happened, and now I hit the magic button. So I will crank up the amperage just a little bit and hit the button once again, and there we had a signal. So let's see what happened. I switch off the laser completely now, and I go over there and have a look. I heard that the laser actually was working, so I just put you on pause. Back again with that news. So with this little current, I actually had no trace of any laser activity at all. What I will do, I will basically just crank down the laser power to the very minimum setting and initiate the laser output once again, and then I think I just go a little bit more power and do it with tiny little bursts. I heard something, and that probably was the protective bag. Let's see. Oh yeah, nice shot. Okay, I prepared everything for that test shot. Everything seems to work like intended, so I've got the right configuration of these switches so far. I don't know if the laser actually would fire if I plug in the supply to the computer, but we will find out in a little bit. For now, I just gonna switch on the laser switch and fire once again. Okay, I set this one to the board so you can see a little bit better what's happening or not, and I probably can see better too. So I switch on the laser power once again, and I just gonna hit that button and crank up the volume a little bit and see. Have you seen that? That's without focusing or anything. 5 milliamps.